Yeah, I need to get my stuff together.
And if you've got your table of values, that would be helpful because that's how we're going to graph y equals tangent of x. So, and I'm just referring to my table now. So 0, 0. I guess we can go out to 2 pi. That's what we normally go out to. So 0, 0. Pi over 4 is 1. Pi over 2 is undefined, so let's leave that blank for a minute. 3 pi over 4 is negative 1. Pi is 0. 5 pi over 4 is positive 1. This is a weird looking graph with what we have right now. 3 pi over 2 is undefined as well, so nothing there. 7 pi over 4 is negative 1, and 2 pi is back to 0. Okay, well, let's pause for a minute. So at pi over 2 and 3 pi over 2, something weird is going on. Why is it undefined? What is the problem? Because it's something divided by 0. So you can't divide by 0. But do you remember from previous graphs, rational function graphs, first semester, if 0 is in the bottom, what that does to the graph? Like if you had 1 over x plus 2, what's happening at x equals negative 2? Do you remember? It's an asymptote. So all those undefines that we have, I mean, they are undefined, but on the graph, they're asymptotes. Asymptotes. So that means at pi over 2, there's an asymptote. At 3 pi over 2, there's an asymptote. Let's go backwards to negative pi over 2 because that will help us see what's going on here. There's another asymptote. And so all we have is like these 3 dots in between the asymptotes. It's going to look like, kind of like an x cubed graph. Something like that. But over and over and over again. All right, y equals tangent, which is sine over cosine. So where are the zeros of tangent? You can look at the picture, or you could look at and think about the zeros of sine. All the pi's, multiples of pi. Because that's the zeros of sine. So you don't memorize a second set of information. You just realize that wherever sine is 0, tangent is 0. And so if sine 0, tangent 0, well, sine is 0 at the multiples of pi. And that means tangent is 0 at the multiples of pi. When cosine is 0, that leads to asymptotes. And you can either think, well, what are the zeros of cosine? Or I can look at the picture and see that there are asymptotes at the, how would we phrase that? Remember how we phrased this? at the odd multiples of pi over 2.
Sydney, you were on the video. I'm so proud of you.
Sydney's on fire over there.
Look, he got that on video. Aww.
It will live forever on YouTube.
Can you tell him I'm on fire too?
Abby, when you're on fire, I will say that you're on fire.
Thank you.
You're welcome. One more thing before we go to our front page of our packet here. I can spell. What's the period of tangent? Think carefully before you answer. Look at how often it repeats.
3.
How much of a window do I need to look at to see the entire thing?
Half a pi.
No, it's just pi.
So if it's half a pi, I don't see everything. If it's pi,
Halves.
it's 2 halves. Now you're on fire. It's 2 halves, which is pi.
Say my name.
Which is what Andrew said and what Abby said. Now you want to be recognized on screen.
And they already know that you're having.
So the period is 1 whole pi. Yes.
Wait, why is it all pi on the graph? I don't know.
All right, so grab this, the front. This is the packet we were working on. Now flip it to that front page.
Oh my god, real like pi here.
He's on video. He's so funny. Thank you.
So let's go through our list here. Maybe we should match it first. It's definitely E because it's the only one that looks sort of like that. So I labeled it. I labeled E. So if I'm just looking at the pictures, I'll know that that's tangent. And then I labeled it E on the graph up there on the table. You just told me the period was pi. So that's a big difference between sine and cosine, or from sine cosine to tangent is the period is different. What about the domain of tangent? Oh, this is kind of tricky. Because it's all real numbers except, right, there were some exceptions on our table and on our graph, places where the odd multiples of pi over 2, except where cosine is 0.
No.
No, I think Andrew is on fire.
He's on redemption. Yes, redeemed.
He's just trying to work his way back to neutral.
That's on video.
That was on video. All right, how about the range?
That was a good one.
All real numbers are negative infinity to positive infinity because it goes forever up and forever down. Ooh, symmetry. Well, let's see. I'll rotate mine. You keep yours the same. I'll do mine the 180 rotation. Does that graph look the same? Yeah. It's moving up, so it's odd. If you could test the even. If you tried to fold it, it would not match over. So it is an odd function. The zeros are the multiples of pi because it comes from sine. Right? Because wherever sine is 0, tangent is 0. And the asymptotes come from the zeros of cosine. So the odd multiples of pi over 2. All right, let's flip to our graphing worksheet that we're spending days upon days upon days with here. Let's look at number 4. Look at number 4.
What are the asymptotes?
The asymptotes are the odd multiples of pi over 2 because that's the zeros of cosine. So the ABCD, it kind of works the same way. Looking at number 4. So what's the amplitude?
0.
What's the number out in front of tangent?
1.
Good. Period. Well, what's B, first of all? 1. B is the number in front of X. The period is pi over B, not 2 pi over B, because our starting period is pi. Our normal period for tangent is pi. So pi over B would just be pi. So this one does not have an adjustment to the period. What's the phase shift? None. And the vertical shift? Up 2. And again, let's use that information in reverse. A, B, C, D, D, C, B, A. So we'll go up 2. For tangent, all we really need to see are the zeros and the asymptotes. If you get those in the right spot, you'll be fine. And they're always, like halfway in between each other. So if you get one of them, you'll get the other one. So tangent starts at, what's tangent start at? Start at 0. Phase shift was none. Period is pi away. So pi away, I have another 0. What happens in between the zeros of tangent? Good. A bunch of people doing this. Asymptote. Well, don't say a line. Let's say an asymptote.
Yeah, Andrew.
And you're right. That means the next 0 is at 2 pi. And the next asymptote is halfway in between there. Let's see, where should we draw next? Because if I draw now, like there's 1 cycle, and it's supposed to have 2 cycles. So let's go back 1 as well to negative pi. And there's 2 cycles. And we could draw more because we have but if you draw more, it's like you got half of the cycle drawn, so it looks kind of funny. Yes, Abby.
So I'm guessing one of those lines counts as 1 cycle.
So a full, that's a good question. Like, how do I know what counts as a cycle? So if you just go 0 to 2 pi like that, that would count as 2 cycles. As weird as that looks. Because it's like 1 full cycle and 2 half cycles. But that's 2 cycles. So if you're comfortable graphing it like that, you can. But most people are like, wait a minute, that doesn't look right. And so most people end up graphing it like that. That's 2 cycles as well. Or you can kind of get carried away and do all of it. And well, you tell me, how many cycles am I showing right now? 3. 2 full ones and 2 half ones. So 3 cycles. So that's more than I need to graph, but most people are not comfortable graphing 1 full and 2 halves. They'd rather graph 2 fulls. And some people will go overboard and graph 2 fulls and 2 halves. Whatever you're comfortable with, as long as there's 2 cycles. Yeah, or you could continue both of those, and then you'd have 4 whole cycles. And then you run out of room. Let's skip to number 13. Not right now, I don't. 13. Oh, that one doesn't look too bad. Try 13. Give 13 a try, and then we'll go over it.
Hey.
You got it right? No, you have write it down.
You want me to write it? Okay. we're teaching today.
Yeah.
Can you move?
All right. I'm sorry.
Okay, so first
Alright.
we're gonna start off and 0 because that has to be done. Andrew, come back. And so because the period is pi over 2, that makes the periods only pi over 2 long.
So you gotta start off by writing it at pi over 2. Put the thing at pi over 2.
Yeah, okay.
Mark it for pi over 2.
I'm trying to see where I put on my paper.
Okay.
Okay, and now we're gonna do regular pi too.
Yeah.
That's
Because
a really
the
thick
zeros.
Yep, those are where the zeros are, and we'll do negative pi over 2 also while we're at it.
Okay. And then halfway in between
Is
them are the
1/4 pi. That's where the lines don't go. And then this is.
Do the asymptotes.
That's what I'm doing. 3/4 pi. Okay. And then this is negative 1/4. Oh, crap.
What did you do wrong?
Negative 1/4 pi. Okay, now it's your turn.
What? Alright.
I'm
I'm gonna take
showing.
one of these. I'm gonna do asymptote. Ah. And then those are the zeros.
Talk to the camera.
Yeah.
Yeah.
These are the zeros, and then halfway in between all the zeros.
Why are they the zeros?
Because they're the zeros.
How did you know that's where they were?
Because the period's pi over 2, and so each period is where each pi over 2 is where the 0 is. So there's a 0 at 0, 0, and then there's one at pi over 2, and if you count another pi over 2 over, it's pi. And if you count another pi over 2 over from that way, it's negative pi over 2. And then,
Got it, yes.
and then you just do the lines. Like that. That's bad. Like that. I'm going to do half this
of
one. And this one goes like that.
3
It's
periods.
just too good.
Write the arrows at the end.
5.
And we're done.
Oh my god.
Hit pause on the video.
Tell them to try 14.
Thank you. I should have let you guys do that as well. Try number 14, and then we'll go over 14. And then, if you're comfortable with it, you can go on. The assignment is basically the rest of them. But go ahead and try 14, and then we'll go over it. All right, let's go over these. A, B, C, D, D, C, B, A. Amplitude, 1, period. Yeah, I'm out of, everybody's gone once, so we don't have to pull. Period's pi over 2. Phase shift is right pi over 4. Vertical shift is 0. So this one is a little bit trickier, as you guys pointed out. The phase shift is right pi over 4. So there's a 0 there. But the cycle ends, or the cycle starts over at pi over 2, pi over 4, plus pi over 2, which should be 3 pi over 4. We get our fractions right here. So 2 over 4, 3 over 4 would be another 0. So there's a 0 at every pi over 2, or every 2 pi's over 4, since that's what our scale is. So that means there's another 0 at negative pi over 4, and at negative 3 pi over 4. And in between all the zeros, so tangent is different, but once you get the zeros, it's pretty easy, because exactly in between the zeros are asymptotes. One of them happens to land on the x-axis this time, or excuse me, the y-axis, which makes it a little hard to see, but when you draw the graph in, it's obvious that there's an asymptote there. So there's 2 cycles. That's all you have to draw. If you want to draw more, you certainly may. 4 cycles. All right, so your assignment is the rest of the worksheet. The rest of this worksheet. So there's sines and cosines and tangents all thrown in.
I'm done for
on worksheet 2. So yeah, we did a lot today. You guys did a great job. And special thanks to our guest host, Abby and Andrew.